Now we will take up the second module. So we have discussed in previous classes that we implement real-time systems using computers, some sort of computers. So I discussed, computers may be made of analog components which are very difficult and may be made of general purpose computers. General purpose computers, it consists of arithmetic logic unit which is capable of doing arithmetic and logic operations, and control unit for giving control signals like read, write, program control, etc. Then there will be some short time memory called general purpose registers for calculations for short time memory, but there is no long time memory in general purpose computer. And to transfer the data between this, means to send the control signal we have control bus, to send the address we have address bus, to send the data we have data bus. Data bus is bidirectional because there is chance of data transferring from the memory device to the CPU or from the CPU to memory device. But address bus is always a unidirectional. That means CPU will be informing memory chip about the address. And the control signals can be bidirectional. And outside this computer, we have to interface some memory, some RAM, ROM, etc. and some IO interface, IO peripherals like 8255 IO ports, etc. So only ALU, control unit, buses and general purpose registers are available inside the computer, and the memory and IO ports have to be outside. Okay. Now features determining processing power and influence choice of computer. So you have seen 8085 is a 8-bit processor, 8086 is a 16-bit processor. So it is word length, means it is at a time how much bit data or operand can be processed. And bigger the word length, the bigger the operand will be. You will be able to do in one time only 16-bit if it is a 16-bit processor. If it is 8-bit processor, if it is a 16-bit data, you have to do twice. So if the operand and result exceed word length, the extra processing is needed to split the operand into different registers. For example, if you have only 8-bit processors and we have to operate on 16-bit data, we have to do twice. You know that procedure. LSD, that will be added first, and with its carry, MSD will be added, right? Which takes up more time if it is splitting is there, so reducing the process speed. So we anticipate a microprocessor with a bigger word length. And the second is instruction set. Instruction is more and more instructions are there, means your performance will be more, means you can reduce the size of the program. And addressing modes, many present day microprocessor control supports many addressing modes, like immediate addressing mode is there, direct addressing mode is there, relative addressing mode is there, index addressing mode is there. So this all has effect on the computing power of a computer. Number of registers is also very important because this decides the fast access to memory between memory and ALU. So to accommodate the data and program which are currently being operated and has effect on the speed and performance of the computer. Information rate, signal change will be there or bit rate will be there, baud rate or bit rate, it has effect on speed and performance of the computer. The higher the information rate, the higher the speed will be. Interrupt structure is also very important because you know that polling is avoided. Whenever IO devices need service of the computer, it will interrupt and the computer gives the service, and there is option for assigning priority to critical priorities to highest priorities to critical tasks. And another option to implement a real-time system is to use microcontroller. Microcontroller is nothing but single chip microcomputer. That means full general purpose computer on one chip. That means in the chip itself, apart from CPU, ALU, control unit and registers, it has got some program memory inside only, small memory, 4K bytes of EEPROM and 128 bytes of RAM. And oscillator circuit is also inside, interrupt circuit also inside, IO ports are also inside. All are available inside the chip itself. So a computer on the chip is called a microcontroller. So it's a single chip device that is specifically intended for embedded computer control applications. It is better for bitwise operation because your bitwise operations are more here. And there are some specialized processors to increase the computation speed, and for safety critical applications some processor may not support. So we make usually using reduced instruction set because instruction set has to be less. Only for typical applications we use them. The advantage of simplifying the instruction set is the possibility of formal verification that the logic of the process is correct. It's simple to verify, right? And we have parallel computer architectures. That means many computers are doing the same tasks. So we have 4 categories: SISD, single instruction stream, single data stream, based on how the instructions are passed and how the data are passed. So single instruction stream, single data stream, single instruction stream, multiple data stream, multiple instruction stream, single data stream, multiple instruction stream, multiple data stream. See here, in SISD, single instruction stream means there will be one functional unit executing one instruction stream. Only one instruction stream is executed by one functional unit, and that is operating on a data stored in a single memory. This is called SISD. SIMD means what? We have a single instruction stream. Okay, single instruction stream is operating on many processors, and each processor work on different data stream, which are placed in a shared memory. From the shared memory, this processor will be operating one instruction stream on data stream 1, different data stream, and the unit 2 for second functional unit is also taking same instruction set. Instruction set is same, but data are different. And multiple instructions in single data means there are many processors which are executing different instruction streams, many instruction streams, but it is using same data on a single memory unit. MIMD means many processors are executing many different instruction streams on different data streams taken from the shared memory. So that this is all about parallel computing. Thank you.